Hello everyone, this is Kirti Nashikar and welcome to my YouTube channel Easy Electronics, where I am going to discuss all the concepts related with the electronic subject and will make you this concept much easier for all of you. So yes, if you like this video, then please like, subscribe and share my channel. So from today we are going to start MOSFET, which is the metal oxide semiconductor field effect transistor. In this, we are going to start with the introduction and its types. Then we will see the detailed construction and its working principle. After that, we will have the input and output characteristic study of MOSFET. And in the last, we have the MOSFET as a switch. So let us start with the very first lecture of MOSFET, that is introduction of MOSFET or FET and its types. So Don Kang was an inventor of the first practical field effect transistor. FET controls electronic signals by switching them on or off or by amplifying them. And amplification, all of us knows that it is raising the strength of the input signal at the output. So that is the process of amplification. And also the switching mechanism. These two things were very much rightly performed by FET. FET is a unipolar semiconductor device. They are voltage controlled and the conduction of these devices depends on only one type of charge carriers, which is either holes or electrons. Okay, that means only majority charge carriers are responsible for the current flow in this device. FET, that is field effect transistor, this name is given because of the fact that the current in the device is controlled by the electric field, and that's why it is also called as the voltage controlled device. So before starting with the FET, we must understand why we have preferring FET over that of the BJT, or we must understand the difference between that of the FET and BJT. So BJT is the bipolar junction transistor and FET is the field effect transistor. So very first difference is the name itself. Now in case of BJT, as we have seen that its operation depends on the two types of charge carriers, that is holes as well as electrons, or we can say the operation depends on the majority charge carriers as well as on the minority charge carriers also in case of BJT. But in case of FET, operation depends only on the majority charge carriers, which can be holes or electrons. In case of BJT, the input impedance is low, but the FET is having very high input impedance, which is in the range of 10 mega ohm or more. BJT is the current controlled device, but FET is the voltage controlled device. BJT is the bipolar device, FET is the unipolar device. The power gain of BJT is low, but the power gain of FET is high. So these are some of the remarkable difference between that of the BJT and FET. So let us start with the FET. Now the FET, which is the field effect transistor, is having two main categories. First is the junction field effect transistor, shortly known as JFET. Second is the metal oxide semiconductor field effect transistor, MOSFET, or also known as insulated gate field effect transistor, IGFET. So MOSFET is high speed switching characteristic device. So types of FETs are JFET and MOSFET. Again, JFET is divided into N-channel JFET and P-channel JFET. These are the two types of JFET. MOSFET is also having the two types, that is N-channel MOSFET and P-channel MOSFET. But the differentiation is also done depending on the mode of operation of MOSFET. So let us see the types of MOSFET. It has two types, as I have discussed, that P-channel MOSFET and N-channel MOSFET. But they are again categorized according to the mode of operation in two ways, that is enhancement MOSFET and depletion MOSFET. So when the MOSFET is working in the enhancement mode, then it is called as enhancement MOSFET, and when it is working in the depletion mode, it is called as the depletion MOSFET. Now let us see the construction and symbols of N-channel JFET and P-channel JFET. Firstly, we will see the construction and symbol of JFET, and then we will have the MOSFET, so that we can easily understand the difference between that of the JFET and MOSFET. So this is the basic construction of N-channel JFET, as you can see here, and this is the symbol of N-channel JFET. Now in the construction itself, we can see that it is a bar of N-type silicon, and this bar is used as the N-channel JFET. As you can see here, this is the N-type silicon bar. Okay, and this silicon bar is having this channel. Channel means through which the current can flow. That is called as the channel. So as it is the N-type silicon bar, so that's why the channel is the N channel, and that's why it is called as the N-channel JFET. Okay. This bar behaves like a resistor between its two terminals called source and drain. As you can see here, there are three terminals. So this is the source terminal from where the majority charge carriers are entering into the channel, and this is the drain terminal denoted by D, through which these charge carriers are leaving the channel. And this is another terminal, which is the G or gate terminal. Source is the terminal through which majority carriers. Now in case of P channel, majority channel carriers will be holes, and in case of N channel, majority charge carriers will be electrons. So from the source, these majority charge carriers are entering into the channel or bar. Okay. And now you can see here there are two P regions. Okay, and these two P regions are internally connected to each other. Okay, they are internally connected to each other, and one terminal is taken out of them, that is called as the gate terminal. The regions between the source and drain, sandwiched between the two gates, is called the channel, and the N channel, in case of it, symbol of N channel, the gate arrow points toward the channel. In case of P channel, it points outwards of the channel. As you can see here, this is P channel symbol, this is N channel symbol. बाकी सिंबल में सेम है, सिर्फ अगर एरो इनवर्स है then it is N channel JFET, and if this arrow is outwards then it is P channel JFET. Here the construction of N channel JFET is discussed. In case of P channel, you have to take the P type bar. Okay, this is your P type bar, and you have to diffuse N type bars or N type materials to the opposite sections of this P type bar. Okay, and you have to draw these three terminals. This is source terminal denoted by S, this is drain terminal denoted by D, and this is the gate terminal denoted by G. So this is the construction of P channel JFET, this is the symbol, this is the construction of N channel JFET, and this is the symbol. Okay, so as you can see here clearly, this is N channel JFET and this is P channel JFET. These are the symbols. Now let us see the construction of n-channel depletion MOSFET. Okay, so this is the construction of n-channel depletion MOSFET. अब MOSFET में हमने देखा है there are two types of MOSFET, N channel and P channel. अब N channel में again two types, N channel enhancement MOSFET and N channel depletion MOSFET. Same for P channel MOSFET also. Okay, now in N channel depletion MOSFET, as you can see here, a conducting wire of N material is taken and a P layer on the right end, an insulated gate on the left is present. Okay, so this is your N type layer और इसमें हमने एक P type layer को diffuse किया है to one of the side, and one terminal is taken out from that terminal through the metallic contact. That terminal is called as substrate. Okay, to the opposite side we are doping SiO2 layer, or we have insulated the SiO2 layer, and the insulation is made between the N channel and the gate terminal, which is taken out from this metallic contact. Okay, the rest of the two terminals are similar as source and drain. ठीक है. Now the free electrons can flow from the source to the drain through the N material. The free region is called the substrate, and a thin layer of silicon dioxide is deposited on the left side of the channel. As the gate is insulated from the channel, negligible gate current flows even when the gate voltage is positive, and as the gate is insulated, so that's why it is also called as insulated gate type MOSFET. ठीक है, so this is the construction of N channel depletion MOSFET. This is the symbol, as the gate is insulated, so that's why we have to show it like this. In case of N channel, now here four terminals are there, as the substrate terminal is also added to the depletion MOSFET, so that's why we have to show the four terminals. Okay, so you can show either this symbol, or in terms of three terminals, if you have to show, then you have to internally connect the substrate terminal with the source. So your symbols become like this. This is for N channel. Now again, in case of N channel, your arrow is in the inward direction, and in case of P channel, your arrow is in the outward direction. Okay, so this basic difference you must be able to differentiate. So these are the depletion MOSFET symbols. As you can see, this is for the four terminals. This is N channel, P channel, and these are for the three terminals, N channel, P channel. Mostly three terminal symbols are used for making the circuit more simpler. Complexity reduce हो जाती है if we are using the three terminal symbol. Now let us see the construction of depletion and enhancement MOSFET. So this is your depletion MOSFET and this is your enhancement MOSFET. अब enhancement में ये जो P मटेरियल था ये पूरा का पूरा enhance हो रहा है या enhance हो चुका है till the SiO2 layer, and that's why it is called as enhancement MOSFET. In N-channel enhancement MOSFET, the substrate extends to the SiO2 and there isn't channel between the source and drain, as you can see in the diagram. Okay, so this is the basic difference between that of the construction of depletion MOSFET and enhancement MOSFET. This is the P substrate which is on one of the side in case of depletion MOSFET, but in case of enhancement MOSFET, the P substrate is extended till the SiO2 layer, as you can see, and that's why it becomes enhancement MOSFET. Rest of the construction is similar. So this is the symbol of enhancement type MOSFET. तीनों layer अलग अलग हो चुकी है, so that's why we have to show them by this dash. Okay, for N channel again arrow inwards and P channel arrow outwards. Insulated gate है, so that's why again the gate is insulated, shown insulated in the symbol also. Yes, so difference between symbols, this is for JFET, okay, N channel JFET, then P channel JFET. This is for N channel depletion MOSFET, P channel depletion MOSFET, and this is for N channel enhancement MOSFET and P channel enhancement MOSFET. Okay, so these are the difference between the construction as well as the symbols. We have also seen the types, and the difference between BJT and FET is seen in this video. In the next lecture, we will see in the more details of MOSFET construction and its working principle. So yes, if you like the video, please like, subscribe and share my channel. Thank you so much.